All right, the vehicle intersection problem is commonly thought of as one of the more complicated um, related rates problems, mostly because you have to figure out what the picture looks like. So you've got an intersection. We'll just draw it right here. So car A passes through traveling east at 10 a.m. So this is car A headed along this trajectory. And at the same time, car B is traveling north through the same intersection. So there's car B headed north. Now, car A passed through at 10 a.m. Car B passed through at 11 a.m. Car A had 60 miles an hour, so dA dt is 60 mph. dB dt, the rate of car B, is, let's see, 50 mph. From this and from the time that has passed, we can figure out how far A and B are away from the intersection at noon. So at noon, car A had been traveling already since 10 a.m., so for 2 hours. So this is going to be 120 miles. And at noon, car B had been traveling for an hour at 50 miles an hour, so that'll be 50 miles. And the question is, how fast is the distance, I'll call it d, changing between them at noon? So let's do this. We'll say that a squared plus b squared equals d squared. And we'll differentiate implicitly that 2a dA dt plus 2b dB dt is equal to 2d dd dt. That's a tongue twister. And then a, we are told, is 120 miles, or we figured that out. dA dt is 60. B is 50 miles, and dB dt is 50. This now is a 5, 12, 13 triangle, so D is 130 miles, and we are left with just one variable, and we can solve for it, dd dt. So let's do that. Actually, let's not do that because I'll need my calculator. In the end, you will multiply all this out and you will divide by 260 and you will get this lovely answer of 74.6 miles per hour.